Hello everyone, welcome to my YouTube channel. In this video, I am going to explain Class B push-pull amplifier analysis. Okay, this is a basic circuit diagram of a Class B push-pull amplifier. Here two identical transistors Q1 and Q2 is used. So the bases of Q1 and Q2 are connected to the opposite ends of transformer TR1, secondary of transformer TR1. Okay, so the emitter terminals of the transistors are connected to the center tapped transformer, secondary of the input transformer, and while the supply VCC is connected to the center tapped primary of the output transformer. Here, VCC is connected to the center tapped output transformer, and emitters are connected to the secondary of the first transformer. That means input transformer. Okay, so this is the basic construction of a push-pull amplifier. Now coming to the working, when the input signal is applied, the center tapped secondary of the input transformer develops two signals, VBE1, VBE2, which are identical but with opposite phase. The transistors Q1 and Q2 are driven by these two signals. So Vi is going to positive, V2 is going to negative. So obviously Q1 becomes on state and Q2 becomes off. During the negative off cycle, Q1 becomes off, Q2 becomes on. So as the collector current Q1 increases from 0, it produces a off sine wave of voltage across the upper half of the primary of the output transformer. Okay, when the positive off cycle of the input signal to Q1 begins to go negative, the signal at the Q2 base is coming to go to positive. So Q1 becomes off and Q2 becomes on. So a off cycle of the voltage waveform is generated across the lower primary of the output transformer. So the effect of these two cycles, the effect of these two off cycles in separate of the primary of the output transformer is to produce a magnetic flux in the transformer core which flows in the first in one direction, then the opposite direction. So the flux links in the secondary of the output transformer and generates a complete sine wave output at the secondary of the output transformer. This is the basic operation of Class B amplifier. So in Class B, transistors are operated at three H cutoff point. That means here the conduction angle is only 180 degrees. Okay, so just observe this figure. So here, just observe this figure. Here, Q point is located at cutoff. So it is also a CE configuration amplifier. So VC is taken on x-axis, IC on y-axis. But it is operated in Class B mode. That means transistors are operated in cutoff point. So this is cutoff point. So only one off cycle is possible. That means 180 degrees conduction angle is possible. So the maximum swing is VCC. VCC maximum swing is VCC. Okay. So I will explain analysis of Class B push-pull amplifier. So here the efficiency is equal to output power by input power. That means AC power divided by DC power into 100. Okay. So how to calculate AC power and how to calculate DC power? That is very important. So first DC power. So DC power is equal to DC voltage VCC into DC current. DC current. So what is DC current? What is DC current and what is DC voltage? Okay, DC voltage is VCC. Fine. DC current is equal to IM divided by pi. So here only one off cycle conduction is there. So just it seems to like a off wave rectifier output waveform. So In off-wave rectifier, IDC is equal to simply Im by pi. So here same logic is applied. So DC current is equal to Im by pi. But here two transistors are used. That's why it is multiplied with 2. 2 into Im by pi. So finally we'll get 2 into VCC into Im divided by pi. Now coming to the PAC, AC output power. So AC output power is equal to maximum voltage Vm into maximum current Vm into Im. Okay, but here RMS values are considered. So Vm by root 2 into Im by 2. That is equal to Vm into Im divided by 2. So therefore efficiency is equal to AC power by DC. So AC power is equal to Vm into Im divided by 2. DC power is equal to VCC into Im by pi. But here two transistors are used. So 2 into VCC into Im by pi. So that is equal to Vm into Im by 2 into pi divided by 2 into VCC into Im. So Im cancel. Under ideal conditions, Vm is equal to VCC. So therefore efficiency is equal to, under ideal conditions, Vm is equal to VCC. So Vm and VCC also cancel. Therefore efficiency is equal to pi divided by 4 into 100. So that is equal to 78.5% efficiency. Thank you.